morning, students.
Good morning.
So today's problem is multiplying polynomial. Is this good for you or too small? Like to just adjust it to make it more bigger in your screen. Okay, so you have seen how to use arrays for polynomials, and in some cases, the arrays can be sparse. That means you don't need several other terms, much of other terms, because they are all zero. So it is sparse. So you need non-zero terms, but most of the elements in an array are zeros. So in that case, it is called a sparse array. So let me show you that if you have a dense array, such as if you have 2, 3, 1, 4, this can be a dense array, but a sparse array can be that you have mostly 0, but you have only one element, 5 here. So you don't need to store those array elements. You have to store only this one. So it is called a sparse array. So one of the application of the sparse array is a polynomial, because in the polynomial, you may represent this as a polynomial that, let me just change this a little bit. You can think about the last one, maybe a constant term whose index of the exponent of that term is 0. Maybe this is 1, this is 2, and this is 3. So this can represent 2x cubed plus 3x squared plus 1x is just x plus 4. And this is 5x cubed. Okay, so in a polynomial, you don't need every terms to be present, as so it is a very good application for a sparse array. But you have learned how to add two polynomials for the sparse array implementations in the last lecture, but you'll just extend it using operator overloading. As you know, C++ provides operator overloading, a powerful feature that enables us to treat user-defined types like built-in types. So let me just scroll this a little bit. Here, you have, actually this is not using the operator overloading, but it is just for creating integers. So you are creating an integer a of 2, but another integer b of 3, and you'd like to add them. So normally in an integer variable, you can use a plus b, but this is not possible in this implementation because it is called add. So in object-oriented term, you may interpret this, in a procedural term, you may interpret this add a comma b in C. So you may interpret this in C, but in C++, you may interpret that addition is a dot add b. So you can take that approach. So this is also possible in C++, but I reinterpret that in object-oriented term. So you are considering that add is a method inside of the object, but as you know, this object is included in integer. So add should be implemented as a method of an integer. So you can see that there's an add method here defined in here. So you can make a new value who has the same value of this A, and B is transferred to Y, and Y's value is accumulated to the value of Z, and you will return Z. So eventually A is not changed. A new value is created and it is returned. So you can use this kind of expression as exemplified here. A dot add B, and you will print C dot value. Value is another member function, another method which is just returning value. So I'll show this, the operation in your Windows W Studio. So let me just save this and switch to the screen. So in command prompt, you can do this in command prompt, or you can do this in MSys window. So I prefer the MSys window. So let me reshare this, sorry. So let me change the code. And 2000 data structure, laboratory 3 for poly. So laboratory 3, sorry, laboratory 3 and poly. So I can type the contents of material. You can make it into the CPP or add into the CPP. Anything will do. So IO stream. So in this case, I just saved that for the space. You can use using namespace std to omit std dot clone in your source. So class int is created here, and main will be created here as a function. So this is not a good style, but you can understand that int a too. So you need integer class. Okay, so you will construct two integer numbers, and third number, the result of it, a dot add b. Okay, you'd like to see out, see that value, and line. So in the integer class, you can check public and private. And in public, integer constructor int x underscore value. So this is very good representation. So once you have integer field of value, you can have an initializer. So this has the same effect to assigning x to the value, but you can use the initializer here. And int value is just a simple function returning the value. So return var, simple, very simple function. And another method is accepting another integer y and int z, whose initial value is var, whose value is actually the receiver of the object, and z dot var is accumulated y dot value. So you can use return z, you can use y underscore value. This is also possible, but I use the value function for just checking the operational value, and also checking, also promoting the encapsulation. So I just save this, and you can just compile this G++, and once you make so you can make it int add. So there's an error. So think about operator C dot value. So this is actually error because there is no field value and it is not public. So you should call value method. So all these complicated math error is occurred due to this omitting the parenthesis. So make int add simple, and the result int add.exe command not found. So in current folder int add.exe and result is 5. So you can do this inside of as a normal class, but once you want to overload operator plus, so you just rename this as operator plus. But let me use another. So let me think about that. Add operator accepting into I. So it is just returning that the add of y. So it is just transferring the operation to add. So in that case, you can use just substitute this as add-on. Okay, so just to make int add again and executing it int add.exe, so you did print 5 as before. But as you know, this is just another name of add. So let me rename this as operator plus. Then you can use that operator plus here. Okay, operator plus. So make int add. Very simple. And int add.exe. The result is same as before. But actually the operator overloading is that this is just rename plus a plus b. That is a secret in C++. So you can use operator overloading like this. Okay, so make it int add. Thing to do. And int add.exe is executed as before. Okay. Any questions up here? No questions. Okay, so the details of this procedure is described in your handout. You can replace the method add using operator plus. Then the expression C can be expressed as follows. You can overload almost all built-in operators in C++ except the dot and conditional and scope resolution operator. And pointer to member, this is not so usable, but pointer to member operator size of and type ID. And other operators can be overloaded. So you can do the similar thing in using Visual Studio Code. So I didn't exemplify that, the Visual Studio Code, but I just, let me just check it. It is properly encoded. I just made a very brief YouTube video, but just to check it, it is not yet uploaded. Let me just check in the drive. Data structure, but okay. So I'll switch it to that screen. So you can jump to that. That your Ninja is properly installed, so they can be performed G++ minus. So this is just a procedure that MinGW is properly installed in your environment. So once it is performed, that you can download Visual Studio Code and just click next to this point. Let me just check it. Download it and click next, and you can find it here. And then in the package sub window, you should build select the C++ and then click it and install it. Once it is installed, the first obstacle is that not just entering the code, but how to build it. That is your first obstacle. So I should stop here. In the terminal, configure default build task, the last one, not this one. And from that build task, just check the command and is default. If it is set okay, then everything will go. So let me show this, and you can switch the source tab and to the similar thing. So let me show this in actual Visual Studio Code here. So let me switch it to here. So I just exemplified hello Visual Studio Code here, and when you are going to build this in terminal window, configure default build task. So as you know, in my case, g++.exe, and you should check the command in the correct D and check that is default. So it is not default. So this may not be the correct build task. Configure build task again. Okay, so in the group menu, just click that the kind is build. So let me just edit this. Group menu, kind is build, and you should check is default true. So you can save this here. And for other build task, you can safely delete those build tasks. Just remove this. Okay. So just remember that MinGW command is properly set, and everything will do. And group kind build is default is true. And you know that this is not saved yet. So save this and close this. And here you can build it using run or terminal run build task. So it is once it is properly installed. So let me just for sure, I'd like to remove this, delete this, and I'd like to create a run build task again. And you can find that hello vs.exe is created here. And then just click plus for a new terminal window. And you can type every command here. Directory wide, so it is, you can check directory. So the contents of directory that the hello vs.exe just created, and you can execute it. Hello vs.code. So you can make today's problem. So let me just copy it into add the CPP, and to save time, I'd like to copy from the other window. How can I copy this? Okay, and save this here. Okay, and you can store it. And let me just run build task again. and int.exe is executed. So just click another command prompt and int.exe. This is executed as before. And this operator is just a rename of add. So if you don't have any add, you don't need any add, you can just replace this as add here. Okay, operator plus. So that is just the meaning of addition. So you can save this to simplify that, and then run build test. Control Shift B is the execution command, and then in your command prompt, int.exe, the result is the same as before. Okay, and you can submit int add to your NeoSPA. Got it? I'll post that movie, that video clip to in public. Okay. So if you are interested in using Visual Studio Code in Windows environment, you can use this. Okay. So if you don't have any question up to here, I'd like to describe today's problem. So today's problem is the multiplication of polynomial. Using the design of sparse already described in the last lecture, write a program multiplying two polynomials. Given two polynomials, say x squared minus 1 and gx is 2x cubed plus x, then you have to multiply them, and you know how to multiply them. So in the space here, okay, I can use this space. X squared minus 1, 2x cubed plus x. So you have to multiply them. Okay, so you have to multiply this term with every term here. So it'll make x cubed minus x. How about the second term? So you can multiply this term with this one, with this one. So that will make 2x to the 5 minus 2x, sorry, I should align this, x cubed. Okay, so you can sum up 2x to the 5, and you know that this is a plus x cubed, so minus x cubed minus x is the result. So that is the same result here. Okay, so you know that this multiplication should be printed, but you are handling the polynomial in sparse array. So let's let's represent for every term as a pair. For example, you know that this is 1 times x squared. And you know that the second one is plus minus 1 times x to the 0. So you need a pair for the first fx. So f, you have a pair 1, 2. And the second pair is that minus 1, 0. For g, it also have two terms. And you know that 2, 3 is the first pair. And second pair is the 1, 1 is the second pair. And the result, so it is described here, 2, 3, 1, 1. And the resulting polynomial may be represented that 2, 5, and minus 1, 3, and minus 1, 1. Okay? And you know, it happened to be the same number of terms, but the number of terms can be different. So in this case, you have two terms here. In this case, 2 terms here. So it has the same number of terms, but that is not always true. So implement the multiplication polynomial in C++ using a class named polynomial. This is required. Sorry for that. This is required polynomial. Note that it can be useful to implement additional operation for polynomial to implement the multiplication. So you have seen that in my previous description, the addition is required after multiplying every terms. So you need addition operation is also needed for the multiplication. Got it? So input consists of two lines, each of which representing a polynomial. An input line starts with k, the number of terms, and all an and n are given for non-zero an. So your program should print non-zero coefficients of the resulting polynomial to the standard output. So this is the first example. This is the first example. So you should print out where resulting polynomial it has 3 terms and 2 to the x to the 5 plus minus 1 to the x cubed plus minus 1 x. So in simplifying that, 2 to the x5 minus x cubed minus x. And how about the second one? This will represent 2 to the x cubed. And this one, x plus 1. So you have to multiply them for 1 to the x cubed plus 1. For x, you need 2 to the x to the 4 and plus 2x. Oh, sorry. This is not needed. Sorry for that. This is not needed. So you have to add them to the x to the 4 plus to the x3. So I have to multiply this. So the resulting polynomial consists of 2 terms, and the first term is the pair of 2, 4, and second term is pair of 2, 3. Okay. So you have to implement your polynomial with a sparse array. Sparse array. Matrix is the next term, next issue. And you have to overload operator times. Okay. For bonus points only. Any questions? There is, it seems there's a chatting screen. Please explain the input. Okay. Should I do this again? Anyway, so let me just, number of non-matrix, number of terms. So Mustafa is asking me that. So let me just enlarge this to show you with this. Okay, so this is good. So let me explain this again. So you have 2 terms, you know that first term is here, and this is the second term, and you need 2 here. And you need another term, first term, and second term, and you need 2 here. Others, as explained before, 2, 1, 2, and minus 1, 0. Okay? You understand. Any other questions? So there's only one person who submitted, but he did not obey the rules. So how about to extend the due time on 6 o'clock tonight, 6 p.m. today? Is it okay for you? Okay, then you have to submit your code until 6 p.m. tonight. Okay, so so if you don't have any further question, thank you for joining to this lecture, and see you on next Wednesday. Okay, bye bye.